So I will talk about data documentation, and it will be an introduction to the data documentation. It's not supposed to be too extensive presentation, and I will talk about some risks when dealing with data documentation and what are the bare minimum practices so we can have good practices for this data documentation. Also, I want to mention that besides being a data agent at Aalto, I'm a postdoc in the CAM department, and part of the things I'm going to show is somehow related with CAM, but it can be also expanded to other areas. So before getting on this wide organized data, um, let's see who wants your data. We usually have these kind of sometimes practices where we just, for quick saving, like a file, sometimes we put on the desktop and sometimes are not too inclined to make everything organized. And we need to understand, and I will go a bit through why we don't usually go into the good backward practices. And so, but it's also very important to mention who wants our data. And what do I mean is how trustable can be our data if we don't have good data practices. So in 2012, there was a paper reported in Nature where there was many attempts to reproduce the results of 53 landmark studies in cancer research. So it's not something very light, it's something very important for the community. It's related with cancer research. And I mentioned that this is landmark studies, it's not any study, it's studies that were identified as very important to the field. And the question is, how many were successfully reproduced? And you can try to guess. It was 21, 51, or maybe 6 or 42. How many do you think were reproduced in this report? So the right answer, if you answered 6, then your answer is right. And I just want you to mention that this is trying to reproduce. It doesn't mean that the papers were forged, but somehow they were not easily reproduced, which represents also some difficulty to have some trusting the data. Okay, so the next question is a survey of psychologists conducted by John Laubenstein and Quilek found 0.6 of respondents surveyed admitted to falsifying data. Almost all say that they have selectively reported what worked. And also, close to 40% said that they decided whether to exclude data after looking at the effect of doing so. And all options are correct. So which one do you think is true? If you are thinking on D, then you are correct. And again, this is, well, the answer A is, of course, is completely wrong, but the others are questionable, like you select data that make your proof more believable it's not ethical correct. Okay, so these are some practices then as researchers we need to completely abandon, and many of them are maybe due to the pressure of having short results and having a lot of publications, and something needs to change. And so what is even the point of making science open? And this open word, I think you might have crossed it, and depending on who you ask to, open can mean different things. For instance, for some people, open means a tool. So it supports the collaboration between collaboration and sharing. So you open your data so others can also reuse it. Also, some people look at open as outreach. So you try to reach the public communication in crowdsourcing science, for instance, making some people that are interested with science trying to reproduce, for instance, your results or to collect like some data for your studies and make people that also participate in your research. Another way of looking to the open world is regulation. So you can think that if you open your data, there will be more people looking at it and checking if it's good data or not. So it will improve the efficiency of science. Another thing is access to this data. So disseminate the dissemination and ensure everyone has access to the results. So it's more in the state of opening that data, and also can be a measure to improve how much this data influence and impacts of research. So these are not exactly the same ways of looking to the world of open, but they are very valid, and I would think that they are all important as well. Also, the funders want you to have like you want to have good data and open these data. So the OECD said that accessibility is good. Why it does it means that, well, it again reinforce open scientific inquiry and encourage the diversity of analysis and opinion, and makes possible the testing of new and alternative hypotheses and methods of analysis. It doesn't necessarily mean that it's these diversities of knowledge and opinion is, I mean, it needs to be science based and data driven. So this is like what it means by testing new or alternative hypotheses. This is very important to remark. Also, it can promote new research because, for instance, I was interested in a specific view of my data, but in some cases, data can be also used for other purposes, and it can promote new research. Also supports studies on data collection methods and measurements, and finally facilitates the education of new researchers. And again, when we need to make some studies, we need to apply for some funding, and we will receive some money from the funders. So it's also important we give back some data that is actually good, it can be reused. And another important aspect of data that we come across is the FAIR principles. And FAIR stands for findable, accessible, interoperable, and reusable. So findable, what does findable mean? That both machines and people, not only people, uh, should be able to find and refine this data. This implies persistent and unique identifiers for data, for instance, like DOIs, or it also implies suitable descriptive metadata to allow the data to be found. So this is what it means to be findable. Another point is the accessibility. So accessible means both people and machines should be able to access data through well-defined and open protocols. Interoperable, it means that both the data and metadata described, it follows some standards, or it can be read by different kind of operating systems, for instance. And reusable, this means also that the data is fully documented in terms of its provenance and who created and in what conditions can be reused. So there are many intricate points in these FAIR principles, and it, when applied, we can have also better data. So this means that I'm going to change, right? So the research data management can be also as a wicked problem. And what is a wicked problem? It's a type of complex problem that is difficult to define. It has no clear solution, And it's often characterized by a high degree of uncertainty, ambiguity, and have multiple independent factors. You can think on the New Year resolutions. Like it seems like so easy to do at first, but then for many different reasons, it's really hard to. And I will just mention some of the reasons. For instance, open science, fair principles, and pragmatic research, they are not quite exactly the same thing. So there's a lot of pushing researchers in one direction, but this directionality is not sometimes policies pull in slightly different directions. Also, data sometimes is not that simple to define, and it be can have a high scope, it can be really big, it can be lost in translation depending on the field you are, it can have different types, and it can change over time. Imagine you have a certain data that depends on the time you observe it. It's really not that simple to work on it. Also, sorry, so the scale and reach can be challenging. It means that, well, if you didn't have many good practices until now, it will be really hard to now try to put the unsorted data somehow. And changes are often seen as negative criticism. So if you tell someone how to do some job, they will think that they are doing a bad job. And it doesn't necessarily mean that, but it how people will feel often. And also, this is another thing about what we already do in our research. Besides doing the research, we need also to know some part of IT. We need also to sort our data in some and have some data practices. So this can be also not um, very enticing to change. And finally, besides, there's no consistent funding, but also I feel that researchers are not rewarded for having good data practices. And so talking about risks when dealing with data, I bring some examples that we can find in the internet. For instance, you can see like many stories where that PhD students were in the final year and somehow they got robbed or somehow, and they even pay like for the robbers to return their thesis to their email. They even provide their password. And because, if these mistakes happen and these things happen quite often, and then you cannot recover your data anymore, and there are many years of your life you just lost in 1 second. So you need to consider the risk when dealing with data. And here there's I bring here a risk matrix that is often used in chemistry when you do need to have a chemical experiments. You can have many risks that they for sure can happen or they might not happen. And then this is the likelihood is. So in this side of the axis, you have it's not very likely to happen to the more likely to happen. And the consequence is like, well, nothing happens and here people die. So you, for sure, if you are in this side of the spectrum, well, you are good. If you are in here, you need to be really super careful. And I think in data, we can apply this data matrix. For instance, if you are dealing with data that is super important and is invaluable, so you need to be extremely careful. Of course, if you are dealing with data that's, well, you know for sure that you don't even are going to reuse it and it's just garbage. You don't really need to waste your time. So you need to consider different risks. And um, so there are many risks. For instance, I already talked about the theft or loss of a device or backup storage. Also, even if you back up, there's the possibility of corruption, and sometimes it's difficult to locate files or relevant versions of the files. And when you do too many copies, and if file naming conventions are not followed, this can lead to the inability to find the right version of a file. I don't know if you already go over this, but sometimes it can be really bothersome. Again, it also you can delete a file accidentally, or some colleagues can use that file without, and then they didn't document that usage. And then it's really hard to know what happened to your data. And if there's no enough documentation about the context, the context, then it's really, really hard to understand what is the data. So data with that without metadata is next to useless. Okay, and some of the file extension you use can become obsolete. So if you have a file from Photoshop that it was like on version 2, you probably cannot access it anymore, maybe in the new software, and you need to you need to have the right software to read, and this is not good when dealing with files. And of course, I think I put in red two very important that it's files containing personal information they need to be um, used with extremely care. And also, for instance, unique data that cannot be collected again. Imagine you have a mummy, and then in the museum just burn, and then you cannot get that mummy again, because that piece of art, or not art, but that piece of um, of historical documentation cannot be retrieved anymore. And where do I even start? So I bring here a very simple example of what can happen in science, namely for instance, I bring this example. So you have Pedro, and Pedro is developing yarns that smell good when you heat them. So Maria synthesizes the yarn, gives it to Karina to knit a fabric sample, and then handles the sample to Pedro. So Pedro here needs to perform the thermal measurements. And after the experiment, Pedro needs to share, and this means to communicate the results with the team. So uh, this is more or less the basic of workflow that a person it might do first. If it plans what to do and how to do and when to do. So there's a lot of related with the planning. And during the planning, already the researcher Pedro can take notes, and these notes can be analogic or can be in the digital format. And then Pedro do the experiments, and finally it documents what happened in the experiments. And for instance, in this case, it's in the optics lab, and it can make the digital documentation. But for instance, if you are dealing with dangerous chemicals, you probably cannot bring your laptop to the lab. So you probably need to take in a notebook. And it's important that you also take these notes into a digital notebook. After that, well, if the experiments are successful, you can go to the next stage. Otherwise, you can go back again to the plan stage or to the do the experiment stage. And this can be a cycle and until you have the intended measurements out if they worked well. And after that, you analyze the experiments and document again, and finally share. And here in the sharing, you need to know that it can be sharing with your team or between different teams, or sharing in a publication or for archiving. And all of these, they have different necessities of documentation. Finally, Pedro put all photos and measurements sharing in a folder, and he thinks everything's fine. Of course, then Maria says, "What the hell is this?" Well, Pedro didn't document well, and so Maria cannot understand. And if Pedro is going to meet with Maria and explain to everyone in a team about what are the experiments, he's going to lose a lot of time. So the bare minimum practice Pedro should do is write a README file. And these README files provides important information about data. It can also have standards-based metadata. But if there's no appropriate standards, you can write a README style metadata in this style here. So what is the format I usually recommend? Well, you know that files can have different type of extensions. So the text file is usually the most foolproof, okay? And you can work with Word or with PDF, or it's better than having nothing. But my recommendation, it will be have a text file, because text files can be read in different operating systems and is very light, and it converts to HTML easily, and you don't need a special editor. And it's also the most future-proof files type. This is a basic template for a README file. So you describe about your data sets, the collection methodology. These are just examples of what should contain a README file. You can also check more in this link about what it should contain, the README file. And this is how it should look, your folders, when having like the experiments, treated data, and then the README file, okay? You can also have like a group wiki page describing like how you should put your data, and there are more good practices in research that you can find in this article here. And finally, I will give now the word to Ilari. So when you want, you can start sharing your screen, Ilari.
Thank you, Pedro. I would like to discuss a little bit about folder organization. And when you have the data and files, how should you try to keep them organized, and perhaps give some hint and best practices I have found that would help you not to get into a mess. Occasionally, if you look at your downloads folder, for example, or My Documents, you might see that there are quite many files from very many different sources and projects. At least that was the case for me. Or if you are a very organized person and keeping everything tidy all the time, you might sometimes get a folder or data from someone else which is not as well organized, and then you have a mess. But it's okay, you can do something about it. So it's about your style. If you are a very organized person, you can try to keep it organized, do some daily work, weekly work, and to keep everything in a shape and organized. Or perhaps use my approach and sometimes spend a longer time, some hours on monthly basis or so, that you are going to just have a cleaning day or some hours for the cleaning. So it depends on the style. You can do it just a few minutes at a time, every day or weekly, or then a longer streak at once. Whatever is your style, but like getting a good system to organize and following and trying to keep the mess away is the only advice I can really give, that I know that would help there. Also, another approach, the computers have a good search functions, whether you are using Spotlight on the Apple OS, or you might have the search bar for the Windows, and they can locate files for you and data for you. They can even look for the content inside the files. But to help and optimize for that search to work, you should have a meaningful and unique name for your data, that you would actually know what words to use as a search keywords when you try to find your data. So if everything has been labeled like data.csv, it would help you a lot if the computer finds 200 results from the past 4 years with files with the same name. Another problem might hit you when you have near to completing your work and project, and now it's time to publish your data. You're given, okay, you should have to publish the data, but there's some sensitive data, personal data that you should clean first, and it's everywhere scattered on the piles of the documentation. And then you have a lot of data that you should go through and find what to publish and what to not. And most likely in the real life scenario, you will try to find a way to not to publish your data. But to be on the open side, a good idea that would have helped was to actually use a good folder structure right from the beginning, so that you would have the sensitive data in one folder and something that you can publish on another. And that's the way to avoid these kind of scenarios, and you will get the open science benefits. Or then sometimes, especially with the academic careers, there are a lot of universities, people come and go, and it might be that you get to continue the work that another person has started. And so there's some questions like, okay, where's the data? From where can I continue? Where was they left off? So for this kind of situation, you could also think about if you would like to, what would you like to know when you are in this kind of situation? What would you ask from the colleague? How would you like to be the data to be sorted, for example? Where would you like to have it stored, to find it? Or what would you like to see in a README file? And you could use these questions and answers when you try to write the README file yourself, or think about the data plan, the locations and structure for your data. Okay, if someone else would have to make sense of this, what would they like to see in a README file? Probably same things that you would like to in a similar situation. So when organizing your data, you can also think about your colleagues or any possible people that might get access or have the data to reuse or to continue where you left work. So keeping your project data so that it's accessible to your team and a common structure that everyone in the team can make sense of are good approaches to avoid these problems. And using a flat structure, not too many level of folders, is best for understandability. And computers, you can use search to look for even if there are a lot of files in one folder. But if you get into very many folders and the folders, then you have to have the mental model in your head. How is the data? How should it be organized? And like the deeper your folder structure is, the more personal it kind of gets. So it's you have a good idea. Okay, this is the logic that how I want to build my folders. But for another person, it might not be as well or as intuitive than it's for you. So preferring flat structure is a good advice here. And the README file, please start it already during the project and keep it updated. So if there's a sudden change in a work or something, then it's easy point to check where to continue and what's happening as it's already updated. So you can very quickly give the work or let someone else to continue from there. So besides avoiding those problems, the benefits for having a proper folder structure for you and yourself are that you can help your work, your own work, the project. If you build a folder structure to support your project workflow, you will have the folders and the data, the phases you will meet in the project. There will be folder prepared for every part of the data. You can keep it understandable and intuitive through logical naming. And you can have the data easily shared, those parts that need to be shared. And you can separate what has to be published, what is sensitive, and even the cleaning and archiving part at the end of the project will be easier when you have spent a moment before beginning to work to plan the folder structure. And planning ahead is like the best thing here you can do, because then you can start using the folder structure right from the beginning when the project, when you only have a little bit of data, and having as the data accumulates during the project, you will get everything in the correct place. And of course, your team will benefit by getting the data available, using the practices that the team has agreed, so everyone will know what kind of folder structure there is. And also you can get benefit. You can't just copy and use the structure that has been agreed with the team. So you don't have to necessarily even come up with your own, you just follow the team practices. And then it's easy to find the data and continue the work of the colleague if needed. And then even for someone else, for the open science and reuse, possible reuse later, people can interpret your data correctly, identify what and how to reuse from everything, and there to help that you can follow the practices of your field of science and discipline, perhaps even with the metadata standards and how you organize your files. And anyway, here again, the README is very helpful for that purpose. So then for practical example from the Aalto Scientific Computing team, there would be a research project named Project, and having these practices visible in a system, there's one directory for the code. So one key concept here to separate the code and the data. So you can have the code in the version control system and track it and run into code from the code folder, and you don't have to copy code here and there for everywhere. And you can easily also reuse some same code between different projects. And having the original data in one place, and perhaps a scratch directory for some data that can be easily regenerated from code using the code from the original that might even not need the backups, and then separate folders for final outputs. So using this, when you work through your project, you can use your code, develop it, have the original data first in the one place, and then work with a scratch folder. And when you are getting it ready, you can have the doc file for the final outputs, and even open data if you can prepare something to publish. And using this along the line, when the project is over, it's easy for you that, okay, I want to back up permanently and archive the code and the doc and publish the open data folder, for example, in Zenodo, but I can throw away the scratch as it's not needed anymore. And you will get very quite easy way to finish your project and clear the table and get the data that should be archived where that one to publish, easy to publish, and then something that's intermediate and you won't need anymore, that you can just remove or save for some time, like 1 year or 2 years for a short time, if there would be something needed later anyway. So this kind of directory structure is quite flat, as it's easy to understand and like documented here. And there are several different examples around the internet also to find. Here's also a link for the source of this original example with a lot of other information about data organization. And not only talking about the folder structure and giving one example there, I would also like to point out that actually naming files and folders is a very important thing to consider. And because names for the files are how you tag the data and make it findable for yourself later on. So that's really actually the key point where to start. So trying to be short and descriptive, at most in being a unique name so that you would use same names for different projects and different files. And then you can even rebuild the folder structure if you are not having the same files in different folders. Then you can even change the folder structure some days if needed. And here also the teamwork is the best to do. So if you can agree with your team what is the name scheme that you will use, then you can more easily find and understand other people's folders, other people's research data. And if you're working with the same team and same research project, that's really one helpful and important way to go. And some ideas that you could include the file names, date, project name or acronym, what is the data type, where it has been, who has been doing the work, version numbers, and so on. So here's one example of this project called Mountain Project, and there's an experiment too done at Kilpisjärvi, and file has been created on December 22. So the good practices here, there are the elements named, what I use explanation for them. So they start with the date using the number 5 date format from the standard. There's a project acronym. It's a meaningful abbreviation for project and the experiment. And here the elements are arranged from the general to specific, date, a project, location, data, version. And also using a 0-1 for the first version will also enable you to go over 10 in the version numbers and still not mixing the alphabetical ordering of the files. So here, for example, some good practices and tips for file naming that you can try on your project. So that's briefly my tips today for the folder organization, and I'm happy if you have yours, other links or sources that you can also share. Here are some sources I've been using for the Aalto Scientific Computing Team data organization page, and the one from the RDM Kit by Elixir project. And ABC for organizing data training by several authors. Thank you. Now I'll pass the ball to Laura.
So my colleagues has been talking about this data documentation and storaging. So what I would like to do now, I would like to concentrate on the final step of the data life cycle, and more specifically, I will talk about how to open your data in a fair way. And before we can open our data fair way, we have to make sure that the data is it's well documented, like the way my colleagues were telling you earlier, and then it has to be accessible and also well described. So these are the things we are actually concentrating on this section in here. So you might be wondering why sharing data in a fair way is important, but it's because it helps make your work more transparent and reliable, but it is they are also like essential aspects of good research. When we are following these FAIR principles, we can make sure that our data it stays useful and easy to find over time, and it's making a bigger difference in the long run. So it's not basically just opening the data, but opening the data that makes a difference. It's the key in here. But let's take a moment to think about why you want to open your data in the first place. So nowadays you basically have these reasons. So you might have the requirements from your funder, or maybe your publisher, you want to publish in some paper, and they are requiring that you need to open the data related to that publication. Or you might have some requirements from your organization, or then you might just simply want to credit your scientific community. But regardless of the reasons why you want to open your data, you should basically always need these reasons beforehand, because different journals and publishers, they may have their own guidelines and requirements for data sharing, and also funders, very often they have their own policies as well. And it's also important to note that most institutions, like Aalto University, for example, and also funders, they generally now have a policy that opening the data should be made as open as possible and as closed as necessary. So that means that you need to also know when you cannot open your data, or when you can only open the part of your data. So it might be that you are, for example, handling sensitive data or personal information, and you might have to do something to this data before you can actually open that, maybe anonymize it or something like that. So how to share your data in a fair way? The best way is through a data repository. The thing is that all good data repositories, if they are good ones, they have these machine-readable metadata fields, and that's the key to making them fair, so that they are machine-readable. So you can think of that data repository, it's like a well-organized library for your data. So they follow the FAIR principles, so they ensure that everything is easy to find, and it's easy to access and also use. And the key feature is that this metadata information. And there are different types of data repositories available. There is a subject-based repositories, general and institutional repositories. And the key here is to find the repository which is most suitable for your own needs and the most suitable for your data. And you also should check if you have a funding, for example, or if you work in institutions or papers that if you want to publish in a paper, that they all might have some kind of requirements, what kind of repository you should share your data. For example, Aalto's recommendation is that you should firstly go for a subject-based repository. If there isn't anything like that available in your discipline, you should aim for general repository in that case. And selecting to repository, there is a few key criteria to keep in mind. So first, you should aim for repositories that don't require payment or registration to access data. But keep in mind that sometimes you actually need to pay something if you want to upload your data into a certain repository. And the second really important thing when you consider FAIR principles is that the repository has good metadata practices, which means that they offer digital object identifiers, DOIs, and they also have clear licensing information. And of course, you want to choose a repository that plans to preserve your data in the long term. And lastly, you should pick a repository which is easy to use for you, obviously, but also the possible reusers who might want to reuse your data. Okay, that's basically all you need to know before you start to share your data. So we can now move on these FAIR data descriptions. But before that, I would like to have a wee break because it's been already almost 1 hour session here. So I have a little task for you. So my colleague, hopefully she's sharing this Flinga link for you there in the chat, and there's a little task for you. So your task is to describe this sweet cat on the screen. It's gone missing. So you have to describe the cat in a way that someone who has never seen the cat before would be able to recognize it. So please click on this Flinga, and I will also share this Flinga screen in here, so we can try to make good descriptions. So try to think about things for the cat. Yeah, okay, name is the name is the good thing, and maybe about the appearance, what kind of color. Yeah. What kind of color are the eyes? Are they amber or gray? Breed is a good thing, yeah. This actually, it's a real issue which happened to me. This is my cat, and I'd only had it like a couple of days, and I thought I'd lost the cat. So I had to describe to my neighbor how the cat was looking. And of course, I didn't have any picture of the cat yet because I've just got the cat. And needless to say, I did find the cat in the end. I'll make it this bigger so we can see better all this. Oh, there is not monocle, but a stripe. That's good. Yeah, lazy and quick. Yeah. Yeah, does it bite? Yeah, character is also good. Okay, I think that we got the picture of this in here. Thanks everyone. These were really great descriptions. So if we wrap up this exercise in here, what we will actually doing here, we are describing the data object, and in this case it was the cat, and we were describing it using metadata. So when we are thinking about our data, before you publish your data, you need to make sure it's properly documented, that this is where the metadata comes actually in. So you can think of like metadata is the source of your data. So it's data about data, and it tells or helps people to understand what your data is all about. And there's two kinds of metadata here. So there is this documentation metadata, and that was what my colleagues were telling about earlier. So that is all the details about the data, how to use it, and so forth. And then there is this archival metadata, which I'm concentrating on now. So that's all about the title, the creators, and description of the data. So that's that kind of metadata. So, and metadata is basically used by harvesting your data by search engines so that people are able to find it more easier. So if you have a really rich metadata, that is according to FAIR principles, because that enables these machines to find your data more easier. Okay, but let's move on to what you need to know when adding your data to a repository. Please keep in mind that what I'm now explaining here are sort of general guidelines and only applying to these general repositories, like for example, Zenodo. So there is a lots of like subject-specific depositories which they have a specific metadata standards. So it's always a good idea to check the repository's requirements and guidelines. But anyway, when you are adding your dataset to a repository, there are three things which people are noticing immediately when they come across to your dataset in there. First is the title, then there is the creators, and the third one is description. So the title, for example, if I look something from Zenodo, I usually, because I think that these general repositories, they don't really have good search properties at all. So what I usually do, I search for with the keyword, and I get the search results, and then I browse what's in there. And if the title looks good, I click on that to get more information about the data. So that means that the title really needs to be clear and descriptive, which explains what your data is about. And about the data creators, you should give credit to everyone who has been involved with creating this data set, and use, of course, real names, not nicknames. And if possible, also adding this unique research identifier or guides, so it's easier for distinguish different researchers who might have similar names. And about the description, which is really crucial for people to be able to understand your data, it's like a summary of your data. So you should explain what the data is about, where it came from originally, and why it was collected. And this will help others to understand your data and use it correctly. So you should think the description like it would be the abstract of your research papers. Okay, so here I have now this example data set and a little bit background information about it. So there is information about how the data was collected, the variables of the data set, the analytical tool, and the way it was analyzed, and then some information why the data was actually created in the first place. So what I'm going to do now, I will guide you through how to create the metadata for this sample data set. But before we move on that, I would really like to show you the actual data set. So it's here. So you can see that there is a lot of like numerical information in here and some categorical ones. And here you can see already some like results from the data set. And how we came up to these are quite actually interesting results, at least for the person who is interested about societal impact in research. But how we actually came into this one and how people can interpret this, we need to look at the metadata. How this data, to be able to understand how this data was created. So I will use this Finnish this metadata tool called Quine to be making a metadata, create a metadata from this sample raw data. You can basically use any kind of metadata tool, but there is available. Also, any kind of repository which has good enough metadata fields, you can use that. For example, Zenodo works fine, but I use this Quine now. I'm not going to go through all of these fields in the Quine, just the things which I think are important to create like a fair enough data set. So first one, what is there is this licensing information. And as a default, this Quine has this Creative Commons license, CC BY. So choosing the right license, it's really important for two reasons. So firstly, it helps protect your work and ensures that people are actually giving you credit when they're using your data set. And then secondly, it will tell people how they can use your work. So repositories, which are good ones, they actually do have all these machine readable licenses. So that is a very fair thing and all. So when you're choosing a license, you should actually consider whether your organization or your funder has any requirements or how you want others to use your work. For example, I work at the Aalto University, and Aalto has these requirements that if you open your data set, you should use the CC BY license. And also, let's say that I've been getting funding from Academy of Finland. And in EU, you also have to, if you have been getting public funding, you also have to share your license with CC BY license. So I don't actually have much choice in here. I actually have to use the CC BY license. But if you wouldn't have these restrictions in here, you can choose the license which best fits your purposes. So you might not want these possible end users or reusers to use your data to commercial purposes. So you can actually prohibit that with the license in here. So here's a lots of licenses available. And one of these licenses is for specifically to prohibiting the commercial reuse of the data. So before selecting a license, you should also make sure that who owns the data and who should get credit for the data. And this will help also you to choose the right license as well. And then another thing which is I would like to point out here is this access type. Usually repositories they will have at least 3 types of access types. This has 4. This has this specific fair data service access type here as well. But usually they at least have this open, embargo, or restricted or closed use access. So the access is actually important to think about. So you know, so you're actually defining who can actually access your data set. So you can use this open, which means that anyone can access that, or embargoed means that people can access after a certain time period to your data. And then there's this restricted use also, or closed use sometimes. And that means that people can actually access only if you give them maybe access to the data set. And by choosing the right level of access, you will make sure that data is used properly and that you follow any legal or ethical obligations related to the data. And talking about this embargoed access, it's really useful when you want to link your data set to your publication. So here is what you should do. So you can first upload your data to a repository. For example, you can use Zenodo for any kind of repository in that matter. And then you can set an embargo to your data set. So that in that way, you will get a proper citation and DOI to your data set. And then you can send this citation along with your paper to the publisher, and you can add that to the paper. And when the paper has been published, you can open your data set. So that's a good way. And there's another ways as well, which will help you to do this kind of cross-linking between the data set and the publication. So in your paper, as I said, you can include this clear data availability statement. There's this citation. And then you should make sure that you cite your data set both in this literature cited section and also in the methods section, if you just can. And also many journals are now providing this so-called credit taxonomy or contributor role taxonomy, which is a system used in research articles to give credit to anyone who has contributed to the research project, not just authors. So that is a good way to actually add, if there's in the dataset creators, there have been somebody involved with that, but hasn't been mentioned in the authors of the paper. And then about this cross-linking, when you are here in the data repository, what you should do is that you should add the information about your dataset also to this repository. Most of them are actually providing this field in here. For example, this Quine is there is this field. You can add related publications here. This metadata can be, even this dataset has been published, you can still edit the metadata of your dataset in here. Okay, so, and if you work in Aalto University, the one thing you can also do, you can use our research information system and add also the dataset information in there. And our team actually add the relations to other content types in there, for example, to project or publication information. So I will share these slides afterwards, so there's some more information about that one. Another things which are important in here are also this, for example, this title. So I have provided here a title which doesn't really tell anything to anyone at the moment. So let's try another one. Okay, in here, this is much better. It's actually trying to already answer the question what, where, and when. So the title should be, as I said earlier, it should be descriptive, and it should actually highlight the main things or the main aspects of your data set. So this is highlighting, this title is actually highlighting research activities and 2 universities. So it's sort of setting it apart from other data sets, maybe in this particular repository, which are handling societal impact. And what you shouldn't use in title, you shouldn't use acronyms, for example, just use general ones, like COVID is okay. But otherwise, I would advise you to, if you want to use acronyms, add them in the keywords instead. Don't use them in the titles. And also, it's not a good idea to name your paper, name your dataset after your research paper, because you should treat this dataset like a own entity. So it would just create confusion naming it after a research paper. And the dataset description, I can actually show this in here in this preview. You get a better picture of that. That should provide like a detailed explanation of data's purposes, the collection and creation, and the methods and analysis techniques of the dataset. And if the description is too long, so because this should only be the overview of your data, then there is this lots of repositories, all of them you can add additional information, and they are most likely they are also important to add, so that the people can actually reuse your data. So, for example, this README file that Pedro was talking about earlier, you can add that kind of information along with your datasets in there. So any extra information which you think will benefit the possible reusers would be really important also to add along this dataset in here. And also that if your field have specific metadata standards, you can use these discipline-specific metadata editors to create metadata, for example, in XML format, and upload it with your dataset. For example, Zenodo, you can do that. Okay, let's see whether I can back in here. And of course, now I haven't been uploading anything in here because this is just a demonstration to you. But when you are actually uploading your datasets in here, you should, of course, make sure that the file format are sort of common ones, like CSV or something like that, so that people can actually open them. They don't need any specific kind of software to be able to handle your datasets. And also they should be named clearly, like and organized in a clear way, like just like my colleagues were telling earlier in here. And of course, this, for example, is fine. It actually has like really rich metadata fields. So anything that you can make the metadata to more richer, more clearer, and lots of information in there, that's of course a good thing. So providing keywords like I have been doing in here, and then there is other things like, for example, this project and funding information is also something like, actually, if you have been getting funding, your funders are actually requiring that you add the relation that this dataset is actually part of this funding. But I think that these are the things I'm actually wanting to show to you in here. So if I just go here, these are the slides you are getting afterwards. But here are these basically these 9 action points that you should remember when you try to share your data responsibly in a fair way. So if you just follow these steps, I don't think you will have any difficulties. So basically that's me. So thank you for your attention. And I think we have time for questions in here, if you have something for me or Ilari or Pedro.